Have a nice day. Today we are going to see how to construct the Turing machines. Here the Turing machines invented 1936 by Alan Turing. He proposed to solve the problems at complex situations and also used to simulate the logic of any computer algorithm. So what he meant, we can solve any kind of problems like computers. It will give the mathematical abstract as well as we can say model, and it will operates on infinite tape divided into cells, each cells holding a symbol, and also follow a set of rules to manipulate the symbols based on the transition functions. So the challenging task is here we have to write the challenging functions, transition functions to proceed and to manipulate the symbols. Okay. So here this is a input tape. Input tape consists of infinite cells as well as memory. We can say cells in the sense of memory. Each cell is holding some symbol. Here additionally we are talking about here blank symbol. In left hand side and right hand side it will be having the blank symbol, and the read write head, this read write head we can say pointer or scanning or scanner as well as cursor positions, generally read write head. So this read write head moves either left or right. So here the main logic is here, this read write head is move left and right as well as scanning the input, and while scanning the input we can replace by some other variable. So why we are replaced by the some other variable, it may be we can understand it is a processed. Okay, so like that either you can replace the blank symbol, otherwise some other variable we can use. For example, a is replaced by x, or a is replaced by y, b is replaced by z, like this. So if you are replacing, we marked as the scanned symbol. Okay, so like that. So if you are reaching the left hand side blank symbol, otherwise right hand side blank symbol, and also we can reach the final state. We can assume it is here, it is reached to the final state. Okay, in between we are going to read the input symbol or scan the input symbols left and right. Okay, so this is a basic logic behind this. So definitely the memory is concerned, the infinite memory, so infinite tape, and also we can handle the huge volume of memory. So tape symbols may be input symbol as well as blank symbol, and input is as it is alphabet input character alone, and read write head or pointers. So this is 7 tuples totally, Q epsilon transition Q naught F. This is fine automation line. Additionally, we are adding two symbol, tape symbol as well as blank symbol, and we are going to see how to construct the Turing machines for even number of years. First, you need to think about how to make it as a even number of years. When it will comes for even number of years. Yes, definitely we are reading the 2a's is considered as a even. So again and again 2a we are repeatedly reading means definitely it will give the 2a's. Okay. So this is a simple transition diagram for a logic how to construct the Turing machines like that. First we have to think over how to make it as a transition diagram. You see here, first start with Q naught and A, and again come back to the Q1. So here you see here 2, 1A, then 2A, 2a. Suppose 4a means 1, 2, 3, 4. 6a means 1, 2, 3, 4, 5, 6. So it will reach the final set. So this is simple logic behind this. The same scenario, how we are going to process in the Turing machines. Okay. So for example, only 2a the process will be easy. Suppose we are having just to read blank symbol. If it is blank symbol, we are going to move the next step. If we are going to move the next a, definitely we are reading the 2a's, then it will reach the final state. We can announce the string is accepted by 2a. It is also even machine. But we go for 10,000 a, how it is possible? 20,000, how it is possible? So everything it was up to any number of any even number of years, the machine will be accepted. So like that we have to think it and need to design that machine. Okay. So here you see the same thing I am going to manipulate using the Turing machine. Here initially blank symbol, 2a only just I processed. Okay. So if it is Q0 B initial state, blank symbol, here blank symbol means definitely it is in the left end. Okay. You are going to process the next. Here what is the logic means, if you are reading 1a, initial state with a, just replace a by blank symbol. So it means actually we are processed. Okay. So that's why first if it is Q0 B, we can move one position forward. Okay. If you are reading A, Q0 A, we can make it as a blank symbol and you can move the next positions as well as the state also need to change. Because you see here, if it is Q0 A, we can reach the Q1. Okay. So Q0 A is replaced by blank symbol and we will reach the Q1. Again you have to check what is the, so what is the transition here? If it is Q0 B, you have to move the same state but you have to move the right. Okay. And what is the next transition rules maybe? Yes. So Q0 to the same state here still, and if you are going to read Q0 A, so as per rule you have to replace A by blank symbol, the state move from forward, then the state is changed also Q1. So as per transition rules, if you are reading Q1 A again, it will change into the B and come back left. So this is scenario. Is here Q0 A is changed as a blank, it will move right. Okay. Then now the read write head is in A positions. Now the input is A and state is Q1. So Q1 A means automatically come back to the left. Okay. So Q1 A, so the A is replaced blank and come back Q0 B. Okay. Again Q0 blank means, so what is the rules? If you are reading, whenever if you are reading Q0 B, you have to move just to right side. So Q1 B. So now guys, Q1 B still it is already processed, it comes under the blank symbol also. So if Q1 B, we can stop. Okay. So like that we have to process. For example, sequence two number of A's. First you have to check Q0 A. So the A is replaced B, then you just move the right. Okay. Then again you have to check Q1 A. Q1 A is replaced B, then it comes under Q0. So Q0 is a final state. Okay. The same thing again, you are going to check 3 A's. Yeah. Q0 A is replaced by B, then move the Q1, Q1A again replaced by B, then come back, that is a come left, yes, Q0, and the Q0A is against Q1. So it is not a final state. So in this machines we couldn't process odd number of A's. Okay. Yeah. So this is a way of making a transition diagram for the even number of A's. You see here, whenever the Q naught A, if you are reading, it goes to the next state, the A is replaced by B. So this is a right directions. Again, if you are reading Q1A, we have to move towards the Q naught and left. So that's your directions. Okay. The same scenario, it will be applicable for n number of n even number of A's. You see here, A, 2A, then A, A, 4A. So like that. Suppose you want to construct a machine for odd number of A's, you just change the final state. So this is a starting state. This is a final state, means definitely it will be working as a acceptance of odd number of A's. For example, A. This is a final state, means 3A. Then 1A, 3A, odd number of A's, 5A's. So like that it will come. Okay. So this is a way of designing a Turing machines. So next class we will see, next video we will see the next problem, one more problems. Thank you.